So, yesterday we went over points, right? We've mastered points, right? Please make sure to turn in yesterday's work if you haven't already. And if you're expecting your work already, tomorrow. Sorry, all right? It's really busy in the life of Neil Solano. So, today we're using, sure, a little bit of points, sure, a little bit of knowledge of the coordinate plane, but we're incorporating it with the famous equation of every single line. What is the equation of every single line? Hint, it starts with a Y. Yes. This, my friends, you are wondering what it is? It is the equation to every single line. So if you're given a line like this, that line right there could be written like this, in that format. A line like this, a line like that, a line like this. It could all be written as y equals mx plus b. Got it? That's your first lesson of the day. So y equals mx plus b, treat it as your best friend. Treat it as your best friend. Y equals mx plus b. The other thing you need to know about your best friend is what that m represents and what that b represents. Does anyone know what the m represents? What does it stand for? Is it slope? Yes, it is. So this is what we're doing today, is finding the slope. Yeah. But tomorrow we're going to find the b. But for right now, how about we know what b is? What does the b stand for? What is the b?
The y-axis? No?
Yeah. It's called the y-intercept. The y-intercept, pretty much the point in which the line crosses, oopsies, the y-axis. That's the y-axis, and it crossed right there, right? Right there. That's all the b is. It's pretty simple. It's so simple that we're not doing that till tomorrow. We got to learn the hard part, which is the slope. What is the slope, you ask? Quite simple, really. So m equals slope. We have to find the slope and the y-intercept of any given line in order to write out its linear equation, y equals mx plus b, right? Because questions ask that. They say, given the following line, what is the linear equation of it? You have to find the m, you have to find the b, you have to put it into the m and the b spot, and then the next thing you know, you found the linear equation to that line. So we have to be masters at finding m and b. We have to be masters at it, finding it visually when given a graph with a line, or mathematically, which I'm going to show you in a little bit. But for today, let's find the slope of a line visually. You ready? So, what is slope again? Slope is the measurement of the steepness of the line. That's the exact definition, steepness. So, I don't want to use that example of the car and whatnot. I'm tired of that. So, let's find how to find the slope. In order to find the slope, You guys might want to write this down. You need to find 2 points. You need to locate 2 points on the line that's given. You need to find 2 points. Do you remember what we did yesterday? Do you remember what I said yesterday? I said a point is only a point when what? Welcome. A point is a point when what? Or what's considered a point for us in this class? When it's right on what? I know I'm phrasing it wrong. I said yesterday a point, we consider points, just in this class, when it's right on the grid cross sections, right? Do you remember that?
You did not say that, but...
Yeah, I did.
No, you didn't.
I have video to prove it.
You didn't say that.
I have video to prove it. All of these are points for us, right? Oh, you're right. I probably didn't say that. You good?
Try that.
Okay. Just because yesterday all we were doing was points. Like locating it and plotting it. This is the first time in which we're finding points on a line. So, okay, that's fine though. For us, a point, there are an infinite amount of points here. But when I say find 2 points, I literally mean find 2 points that are exactly on the cross sections of the grid. So in this line right here, is there a point in which it crosses on one of these marks? Right on the crosses. Your job is to find 2 of those. So tell me when to stop. I'm going to start right here randomly in this point. And I'm going to go up. Tell me when should I stop. You're telling me that's a point? Good. Do you see how it's right on the cross sections of the grid? Do you see that? Right there? That's 1 point. Your job is to find the second one. Where's the second one at? Let me go up and tell me when to stop. Is that another one? Do you see how it's right on the money? Right on the cross sections? That's step number 1 to solve this for slope. Find 2 points. Okay? I do not want you to pick this one right there. Or pick any random one. No. You're looking for the point right on the money. All right? Why? Because now comes step number 2. Finding the slope. How do you find the slope? After you found 2 points. Easy. The famous rise over run. Does that ring a bell?
Yep.
Does that ring a bell? Rise over run. Rise over run. What that means is pretty simple. Start on a point. And count the steps it takes to rise until you get parallel to the next point. So in this case, you start on this one right there. You go 1, 2, 3. Right? Let me use a different color. 1, 2, 3. Whoa!
Use green, dark green.
I'll use the same one. 1, 2, 3. Right? So far, my slope is 3. Rise over run, right? So now I must run. 1, 2, 3, 4. 3 over 4 is my slope. So slope is written as rise over run. That's how the slope is written. Rise over run. Find 2 points. Do the rise over run. And you found the slope. That's how simple it is. But what gets confusing? Obviously, when you get confusing stuff. Let's say you're given a line like this. You're given a line like this, right? Where are my 2 points? Well, I'm going to pick them just to save time. I see there's one right there. Hopefully you guys saw that too, right? And the other one is right there, right?
I saw another one way down.
Yeah, there's many. There's many, but you just need 2. You just need 2. And let's make this example even better. Let's say you didn't see that one right there. Let's say you missed it and you spotted this one over here. People, that's fine. And I'm going to show you why. But the example that I'm trying to show you is something weird that you have to keep note of. So let's say you decide to do the rise of a run, right? Huh? How do you find the point? Look at the grids. You see all these grid lines behind? Do you see all those grids? You're looking for the one in which the line, this line right here, passes those cross sections of the grid. So this one, if you notice, it's right in the middle, right? Do you see that? If you picked any other one, I don't know, like this line, this point right there, is it right on the middle? Is it? No. The middle is right there. It's off by a little, right? It's just a little above it, right? So it's your job to locate on the line, on this line right there. It's your job to find, it doesn't matter how close or how far, just at minimum 2 points. 2 points. So I said this is one right here. Doesn't matter how far apart it is. You just need 2. So let's do our rise over run. Let's say you want to start on this one to get to that one. It's fine. It doesn't matter. I'm going to show you the 2 ways. How much do we rise by? 1, 2, 3, 4, 5, 6. Right? So far my rise is 6. And then how many steps do we take to get to that one? The thing is, it's rise over run. Running means going that way. We're trying to go the opposite way, right? We're trying to go backwards like this. 1, 2, 3, 4, 5, 6, 7, 8. The thing is, I didn't run 8. I reversed 8. Whenever you have to do that direction change to get to the next point, you throw the negative. It does not matter where you're at. It doesn't matter if you're over here in the positive side. Or remember yesterday I showed you the 4 different coordinate planes, how x is negative but y is positive, and x is positive, all that. It doesn't matter where you land. It doesn't matter where your point is. You focus more on your directioning. In this case, I went -8. How about the other way? Yeah. So there's this example right there, right? It was 6 and -8. Yeah. Let's say you started on that one. Yeah. It's fine. Do you rise or do you fall? You fall how much? 1, 2, 3, 4, 5, 6, right? Because you fell, it's -6. But here, do you reverse or do you run? 1, 2, 3, 4, 5, 6, 7, 8. Because you ran, you didn't reverse, it's a +8. They're both the same thing. That is why, my friends, slope is written like this. The negative is in the middle. If you ever see a slope like that, it means, hey, one of these has to be a direction change. Doesn't matter which one, because it's going to give you the same line. But one of them, you have to change your directions. Instead of doing the traditional rise over run, you're either going to fall and run or rise and reverse. Does that make sense? But wait, there's more. You got your slope, right? Always make sure whether your slope could be simplified. Could this be simplified? 6 over 8 to what? This could be simplified to negative 3/4, right? Negative 3/4. Well, what does that mean for us? If my new slope is negative 3/4, does that mean I'm going to hit another point that was closer? Yes, that's exactly what it means. Let's say you started on this point right there. It doesn't matter. And you rise 3, 1, 2, 3, but then you reverse negative 4, 1, 2, 3, 4. Did I hit another point?
Yeah.
Right there. That's the beauty of it doesn't matter how far apart you get your points or how closer. As long as you always check whether your slope could be simplified, you could hit another point. This is rise over run right here. I mean, this is slope. Exactly, it's like stairs. You need another exam? Let's do it. Yes, I was going to do it anyways. So, that's slope, though. What else must I show about slope? What else? Oh, some other stuff that you need to know. Some easy notes. You might want to take note of it. A vertical line, I shouldn't use that example first. I'll do this example first. A horizontal line instead. A horizontal line, if you ever see that, that's easy. Easy peasy. The slope is 0. All right?
Yep.
Take note of that. The slope is 0. There is no steepness, right?
No.
It's 0. A vertical line, however, who here knows what the slope is? A vertical line.
Something I can't remember.
I have a 1.
Is it negative
I have a negative 0, which doesn't exist, by the way.
0? It's the
It is undefined. Yeah. Yeah. So if you ever get a weird question, for all of you that are taking the WOM map and my quiz, if they give you 4 different graphs, and they say which one of the following graphs shows an undefined line, easy. You just get the one that's vertical.
straight down.
Straight down. But they actually might change it up also, but basically vertical line. So 0, undefined. But now, back to the regular slope. How to find another regular slope. Are you ready? Jesus. Louise. You know what?
I see more points. I see all the points. Almost all of them.
Right? So again, what's considered a point for us? When it's right on the cross sections of the grid. So we're going to go along this line and just pick 2 points that we see. I'll tell you what point I see. I only see 2 points. I only see 2 points whatsoever. The only 2 points I see is this one all the way over here and this one all the way over here. I don't see it. I'm a student that's on the test. I'm panicking, and all I see are those 2 ones. Guess what? It's fine. I'm pretty sure you guys see 2 closer ones, right?
I see more. So.
It's fine. Get the 2 farthest one. It doesn't matter. Let's show our skills of rise over run. So, what point do you want to start off with? It don't matter. You want to start with that one? Okay, let's do rise over run. How do I get to this point? Do I rise or do I fall?
Fall.
So, count those steps. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. My rise is 10. Oh, sorry, negative 10. Thank you.
Fall.
Because you fell, right? Negative 10. Then you ask yourself, how many steps does it take to get to that next point? Do you reverse or do you run?
Run.
Which means my answer is going to be positive. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Could negative 10 over 10 be simplified? To what? Negative 1. Use the calculator. And then you're there like this. You're like, what? Did I miss a point? Let me go check. If I go, if I go back to this point and I decide to go down, oh, by the way, quick note. A whole number, what is it always over? It's no, not in this case. It's always over 1. Not a negative 1. It's not a negative 1 over a negative 1. It's any number, negative or positive, is always going to be over 1. So if in this specific case, yeah. But we like slopes in fraction form because we can visually see rise over run, right? So just think of it like that, negative 1 over 1. Your answer is going to be just negative 1 as a slope, but a lot of students get confused. They're like, it's negative 1 as a slope. What do I rise by? What do I fall? What do I run? What's that? It's just negative 1 over 1. Your rise over run. So how about we rise negative 1, or in this case, we fall, right? We fall negative 1, but then we run 1. Did I hit another point?
Yep.
Then by default, that means if I fell 1 and then I ran 1, I hit another point. Did I?
Yep.
Yeah. It doesn't matter if you accidentally don't see the 2 closest ones. If you happen to get the 2 farthest ones or the median one, it doesn't matter. You could always simplify your answer and check whether you missed some points along the way.
How about if the top and the bottom is both negative?
That's a positive. Oh yeah, let's do that example now. Yeah. You don't believe me? You don't believe me? I'll show you. This is a hard one. Where are my points? What the heck? There are 2. I just
Yeah, I see 1. I see 1.
I only see 2. I only made it to hit 2. Oh, I shouldn't have used this example.
I see 1 and I see another 1. No. Yeah, this is...
No, I
No.
have
Dude,
Okay, that was my bad. I was
And it moves 12.
okay.
2 now.
So where's my 2 points at? If I get this one,
Yes, that's allowed to.
let's say you got, you know what? Screw it. You got that one.
I see the closest one too.
Again.
He went to the
Huh?
really far away.
I was just looking.
So let's do our rise of a run. Here, you could start on this one and do rise, and then you could run. And you already know right off the bat it's going to be positive and a positive, right? What if you were one of the students that wanted to start on that one to get to that one? Well, simple. Do you rise or do you fall? So you fell 1, 2, 3, 4, 5, 6. -6. Let's say you wanted to get to that one. Do you reverse or run? 1, 2, 3, 4, 5, 6, 7, 8, 9. -9 simplifies down to what? Positive 2/3. Positive. And that, my friends, is a positive line. So, are you ready for some tricks to keep note of? Some tricks. Yes. So, to right off the bat, when given a line, to right off the bat know whether your slope is negative or positive, draw a car. Draw a car. Do this. Draw a car with its hood always towards the right. And ask yourself, is it going up or down? It's going uphill, right? That signifies a positive slope. If you were to be given any other line, doesn't matter, like this, if you were to draw a car like this now, again with its hood to the right, is it going downhill or uphill? That means it's a negative slope. Those are 2 cool little tricks. All right?
Should we try it now?
No.
Not a car.
No, because now we gotta learn how to find the slope mathematically. Oh yeah, damn you. You know it all, don't you? So again, this is graphically. This is how to find the slope graphically, how to find it visually when you're given a graph. This, my friends, is a traditional problem. WAMAP, quiz, test, GED, everything. They could give you this and be like, they could ask this exact words, exactly the way a traditional question might ask. A line passes through points at coordinates 1, 4, and -5 and 2. What is the slope of the line? And you're just there like, what? Right? And some people, oh my God, some students amaze me with their creativity, right? They get this and they're like, okay, those are my 2 points. Let me draw a graph. And then they start label everything. And they literally go find -5 and 2. Then they go find 1 and 4. And then they draw the line. And then they do the rise over run. And they're like, oh, finally, right? I found my slope. And it's probably off by a little bit just because they did it all by hand anyways, right? No, that's not what you do. you could find the slope of these 2 points mathematically. And it's pretty simple. We use this little thing called a formula.
Yay! Oh, I love this one.
There's a formula that you guys in the GED do not have to remember because they provide it to you in a formula sheet. For the wall map, I really don't know. I should really look into that. If they don't allow you bringing in, or they don't allow a formula, they don't give you a formula sheet, then guess what? You guys are going to have to memorize this formula. It's a famous formula called the slope of a line formula. And it's this right here. y2 minus y1 2 minus x1. That dishes out the slope easily. So, ask yourself, the only hard part is determining what is y2 and what is your y1 and what is your x2 and what is your x1. That's the hardest part. And I'm going to teach you that trick of how to know when something is something. So, remember how points are written? Points are written just like that. It's written as x, y, right? We did that yesterday. It's the same thing here. It is the same thing here. This is my x, this is my y, this is my x, this is my y, right? The thing is, because this is my first one, literally, that's my x1 and that's my y1. That's the only thing. Because this is my second one, this is my x2 and this is my y2. That's all.
Can we switch it?
No.
Can we do the second? Will be a first?
Yeah, but don't worry about that. Just keep in your head at all times, this is my x1, this is my y1, this is my x2 and this is my y2.
I like this.
All right? And again, just like before with the slope example, remember how I said go along this line and at minimum just pick 2 points. Doesn't matter how far apart it is. Same thing here. If they were to give you more points everywhere, you just need 2 points. Whether it's this one and that one, or the way it is right now, this one and that one, or you went for these two, you just need 2 points. Doesn't matter how much points they give you, all right? In this specific case, we just have those 2. So we get them and we input it into our formula. Do you remember what I said a couple weeks ago on evaluating expressions week? I had a rule. The rule was when you substitute a variable with the number, what must you do first? Whoa, really? Did everyone forget my rule? Huh? Yeah. That was a full-blown rule that I made everyone write down. I even put it in the quiz. That's what you do here. You might not need to for this specific example, but it's going to come handy because people get negatives confused with their subtractions. And as long as you just put parentheses, it's impossible to get your negatives mixed up with your subtraction signs. It's impossible. But anyways, let's solve this. What should go right there? What should go right here? What should go right there? What should go right there? You put it in the calculator, you solve it, boom, 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 you got your formula. Let's do this. What's 2 minus 4?
-4.
What is -5 minus 1?
-6.
Could your slope be simplified?
Yes.
To what?
1/3.
This could be simplified to positive 1 over 3. You found your slope. And they could have taken it up a notch, right? They could have given you 4 different graphs, right? Now you just find the graph with that slope, and boom, you're done, right? Now you match the graph with those 2 points, and blah, blah. There's so many ways that graph questions could be thrown at you, but as long as you understand the concept of it all, you're good. This is the mathematical way. The other one was the visual way. Woo! How did we all like that?
Yeah.
Graphing.
That came from math and geography.
So, that, my friends, is what we're doing today. We are finding slopes, and only slopes, mathematically and graphically. So let's do this.